All right, let's go look at, I guess, a couple of more examples and then we'll be done with this section. So I have a rational inequality in part B, and I'm going to go factor everything and find the critical points. So we've got 3x plus 5, and it looks like we have x plus a 7 and x minus 5 to factor that out. And we already have the 0 on one side, so we're good to go. Now the critical points, again, from the numerator, I have 3x plus 5 equals 0, which means x is negative 5/3. And from the denominator set to 0, I have negative 7 pop out and also a 5 pop out. So my critical numbers are going to be jotted down. So I've got negative 5/3 to the left of negative 1. I've got negative 7 and 5. So I'm going to go make my 4 regions. And since all the multiplicities are 1, odd, I'm expecting the signs to alternate. So let's use x equals 0, the easy one. And when I put it in my original or factored version, I'm going to end up with a 5 on top and 7 times negative 5, and that's positive over negative, which is negative. So I'm guessing it's going to alternate and become positive on this side, positive on this side, and negative on that side. And again, alternating because all the multiplicities are odd. If they were even, then they wouldn't alternate and you would have the same sign on both sides of the one with the even multiplicity. But if you want to double check, you can always go plug in some points. For example, I picked 6 and I got positive over positive. I picked negative 5 and I got these kind of signs when I put them in the factored version. And that gave me negative over negative, which is positive. And when I put negative 8, I got negative in all the 3 factors. And that's a negative over a positive, which is negative. Now the problem says, give me the stuff that's greater or equal to 0. Therefore making it positive. Positive stuff is greater than 0. So here and here are my solutions. And then I got to be careful about the stuff that comes from the denominator. I cannot include those because they'll make the denominator 0. So for those numbers, I'm going to leave it open. So at negative 7, open, not inclusive, and at 5, open. Otherwise, the equal sign I keep for all the other critical points. So only the ones from the denominator, even though this problem has an equal sign, I cannot include it in my solution. So negative 7 to negative 5/3, union 5 to infinity is what my solution tells me. And I will go look at the graph of this on our TI to make sure that those are the places where this rational function remains positive. All right, so we have our rational function input into our y equals. Remember, parentheses around numerator and denominator. Then I'm going to do a zoom 6. And there's my rational function with 2 vertical asymptotes, it appears, and 1 horizontal asymptote, which looks like it's the line y equals 0. So if I'm looking at this graph, again, we know based on our knowledge that at 5, there's a vertical asymptote, and at negative 7, there's a vertical asymptote. And since the degree of this rational function on top is a 1, and in the bottom is an x squared, my HA, not that they asked for it, but the degree in the bottom wins, it's bigger. So I also have a horizontal asymptote. And notice this function crosses the horizontal asymptote at that point. In any case, we're looking for stuff that's greater or equal to 0. So we're looking at when this graph is positive above the x-axis. Those are the only 2 regions I see that are above the x-axis. Hence, the y values are positive. And the x values that cause those y values are basically from here on, which happens to be from 5 to infinity, like we have here. And also in this region, which happens to be between, I guess, negative 5/3, that must be an x-intercept, and the left edge happens to be negative 7, the vertical asymptote, which gives me the first piece. So in those 2 regions, the y values are positive, if we were to look at the graph only. Now let's go look at the last example, and this time we will just use the TI and not go ahead and do it by hand, because we know how to find critical points and everything. Now in this case, since I'm using the TI, so I'll put for the directions, use the TI to do this. I'm not going to move the 2 to the right or left. If I were to move it to the left and compare it to 0, if I'm doing this algebraically, it would be a little bit more work because I would have to get an common denominator and combine the numerators and then factor the problem and pop out my critical numbers. So since I'm using the TI, I'm just going to see when the y values, when the function is greater or equal to 2. In other words, y values above 2. In the previous ones, we would always compare them to 0. So if we had a 0 on one side, we would say, when are they above the x-axis? Or if they were less than 0, when are they below the x-axis? Now, the x-axis, remember, is the number y equals 0. Now I'm comparing it to the number y equals 2. So let's go look at our TI quickly and see when this rational function will stay above the y value of 2. So we've got x minus 2 divided by 2x plus 5. I'm going to do a zoom 6 to look at the standard graph, and that's what it looks like. And we're interested in not only when the y values are positive, but this time when are the y values greater or equal to 2. So when I'm looking at this, I basically have a y value of 1 and 2 there, and I'm interested in when are the y values above 2. So here is the part I'm interested in. What x values gives me that piece only, because that's when the y values are bigger than 2. Below that line, all the y values are smaller, and down here, below the x-axis, the y values are way smaller. So I'm trying to see what x values gives me those y values. And I also got to be careful because it looks like this problem has a vertical asymptote from the denominator. If we pop out the critical point, it's going to be negative 5 over 2. So it looks like negative 5 over 2 is going to be a vertical asymptote, and I'm getting close and close to negative 5 over 2, but not ever equaling to it. So I just need to find this point so that I can say that, hey, between this x value and this x value, all my y values are remaining above the line y equals 2. Y equals 2 is my reference point because of this 2 on the right-hand side of my inequality, because I chose to just compare it to 2 as opposed to moving the 2 over, doing all the math and comparing it to 0. Now let's go on our TI, back to the TI, and see how we can do that. If I go to y equals again and put the line y equals 2 and look at the graph, it'll tell me exactly where it cuts through it, and it looks like it's at a negative 4, but if I'm not sure, I can do second trace and use the number 5 feature, which says intersect, and that'll help me find that intersection point. Now my cursor is near the origin. I'm going to move it up, I guess, to have it jump to that line, and then also jump. I'm going to make it close to that intersection point. That way my first curve and second curve are near each other and the calculator can pick it up easily. Because if I have it too far, then it may not be able to get me that intersection. So it says first curve, I push enter. Then it jumps to the second curve. It says, is this the second curve? I push enter again. And then the third one says, should I guess? I push enter again. And yep, it looks like the intersection point happens at negative 4. X is negative 4 at that point, and 2 for the y value, as we would have suspected anyway. So basically what I have a negative 4 there for my intersection point. So my solution is between negative 4, because there's an equal sign. I'm going to include the negative 4. And it stops at this critical point, which is the vertical asymptote negative 5/2. And I cannot leave it closed because that's a vertical asymptote and comes from the denominator. So I have to leave it open and say, hey, all the x values that give me the y values that are supposed to stay above the y value of 2. So in this region, the x values that allow me to do that happen to be between -4 and -5/2. So that's my solution if I'm just simply looking at the TI and visually picking it out. So I'd like you guys to be comfortable with doing it algebraically, especially if there's zeros on one side already. And then also knowing that that number that's on the right side, those are the y values you're comparing your graph to. Do you want the y values to be bigger or smaller than those values? In the previous cases, it was the y value of 0. In this case, it was the y value of 2, and that's why we had to have a reference point of when the graph ends up being above that.